All right, so back on our board notes, this was something we pasted into our board notes last lesson, and we can see in the red boxes, that's what's highlighted on our reference sheet. And you can see over here on that first one, it's got y equals ln of x, and dy under x, the derivative of ln x was 1 over x. And we just saw that on Desmos. And then we can stretch that further to any kind of function. So if I have y equals ln of some function, the derivative of ln of some function is the derivative of the function over the original function. And if we go back to ln of x, the derivative of x is just 1. So the derivative of ln of x follows this pattern. Derivative of x is 1, and then I put the function at the bottom. Much like the derivative of e to the power of x was e to the power of x. That same pattern applies, that e to the power of some function is the derivative of the function times e to the power of the function. And what was the derivative of x? The derivative of x is 1. So dy dx is 1 times e to the power of x. And if we scroll down, we can look at some examples here. So if I have ln of 5x plus 1, what we're looking for with ln of 5x plus 1, well, what is the derivative of 5x plus 1? The derivative of 5x plus 1 is just 5. So our numerator is 5, and the denominator becomes 5x plus 1. A second example there, what about e to the power of x squared plus 3x? Well, what is the derivative of x squared plus 3x? The derivative of x squared plus 3x is 2x plus 3. And then you can see that's multiplied by e to the x squared plus 3x. And then all our other rules, our quotient rules, our chain rules, our product rules also follow along. So if I have the derivative of x ln of x, that's product rule. So I set my u's and my v's up. And remember, product rule is u dash v plus v dash u. So if we say u is x and v is ln of x, we set up our stuff. And down the bottom there, you can see that I have u dash v, so 1 times ln of x, plus v dash u. 1 on x times u, and notice there's some simplifying. So again, take the time and simplify where we can, and our answer becomes ln of x plus 1. And then quotient rule, we can see up there, e to the 2x over 2x plus 1. So our quotient rule is u dash v minus v dash u all over the bottom squared, or v squared. So setting up, remember that if you set this stuff up and you then try to put it into the fraction somehow, that's an attempt at using the quotient rule. And we go through, and you can read that along there, that the derivative of e to the 2x is 2e to the 2x, and the derivative of 2x plus 1 is just 2, and then we multiply and subtract what we need, and simplify our fraction where we can as well, and we get to our answer. Moving this through to an example that requires a bit more of an understanding of not just finding a derivative, but doing something with it. So for the curve, f of x is equal to e to the power of x squared. At the point 1, e, find the equation of the tangent. Now remember that e is just a number. It's 2.7 blah, 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 blah. So when we put e into a coordinate point, it's still a value. So find the equation of the tangent. Right, so tangent means we want the value of f-1 at 1, because that will become the gradient of our tangent. So let's go through. We've got f dash of x equals, well, the derivative of ex squared is the derivative of x squared multiplied by ex squared. So the derivative of x squared is 2x, and now we just multiply that by e to the x squared because it stays itself. That's its derivative done. Now we need to evaluate it at 1 to find our gradient. Remember, using brackets when we substitute in so we don't get confused about the negatives. 2 times 1 is 2. E to the power of 1 squared is just 1, and e to the power of 1 is just e. So that ends up with 2e. So now we know the gradient of our tangent. We can go through and find its equation. So using the point gradient formula, y minus y1 equals m outside of x minus x1. Y minus, we'll remember the point we were given was 1e. So y minus e equals our gradient, which we said was 2e, outside of x minus the first x coordinate, which is 1. And now all we're going to do is we're going to expand the brackets on the right. We're going to move that e that's on the left-hand side over to the right-hand side of the equation, and we're going to come up with a statement in the terms of y equals mx plus c. Now, some textbooks and some questions may say give your answer in the general form. In general form, that means we want everything on one side of the equal sign. Our x value must be positive. So to get it into general form, all I need to do now is move the y across. So I can get 2e to the x minus y minus e equals 0. And that's the general form. Let's go on to another example quickly. The second and last example we're going to look at this morning is this one here. So again, an application of derivatives. And the displacement of a particle is given by s equals 10e to the 2t minus 5t centimeters after t minutes. So that means our rate of change is given in centimeters per minute. That's our rate. Part A asks us to find the average rate of change. Well, the average rate of change is just the gradient of a straight line. So if we pick 2 points on this curve and drew a straight line between them, a secant, what's the gradient between those 2 points? And we're going to do that by rise over run. And remember, rise over run is y2 minus y1 over to x2 minus x1. So I need to know the value of the curve at s equals 1 and s equals 5. So that's going to be my numerator. And my denominator is just going to be the 2 x coordinates subtracting each other. So I'm going to do 5 minus 1. So that means the first number in my numerator, the y2 value, is I'm going to evaluate s at 5. So we're going to have, so that's my value at 5. And from that, I'm going to need to subtract y1, which is evaluating at. Remembering that we want to see these values substituted into these formulas, and we then chuck that on our calculator, and when we press equals, we get, and there is our average rate of change. Right? If we go to part B, it now says find the rate of displacement. The rate of displacement. Now, when we're talking about the rate of displacement, that is the derivative. And when I say the rate of displacement after 8 minutes, that means I need to sub 8 minutes into our derivative. So if we think, well, we just find its derivative to start off with. So s dash equals, well, remember the derivative of e is the derivative of 2t, and we times that out the front. So we're going to end up with 20. Actually, let me write that differently. The 2 comes down the front and multiplies the 10e, and the 2t remains because e is its own derivative in that sense. And the derivative of 5t just becomes 5. So we end up with 20e to the 2t minus 5. That's our rate of change. That's our velocity, because we're talking about displacement. And it asks, after 8 minutes, s dash becomes 20e to the 2 lots of 8 minus 5. And we just now sub that on our calculator. in these kind of questions, it's important not to forget your units. And it's okay that it's quite large number because we're dealing with, if you think about E is 2.7. We're raising 2.7 to the power of 16, and then we're multiplying that by 20. So that's getting quite large quite quick. So we would expect a very large value. And that is it.